Romex cable is generally not permitted in Type 5 of wood frame assembly use buildings. The National Electrical Code, or NEC, governs the installation of electrical wiring in buildings, and it sets restrictions on the types of wiring methods that can be used based on the building's construction type, occupancy, and fire rating. Type 5 of construction refers to a specific classification of building construction, typically involving wood framing. Assembly occupancies are those where large groups of people gather, such as theaters, restaurants, and places of worship. The primary reason Romex, also known as non-metallic sheath cable, is typically prohibited in these types of buildings is due to its flammability and lack of fire resistance. In the event of a fire, Romex can quickly burn and contribute to the spread of flames and smoke, posing a significant hazard to occupants. Furthermore, Romex's plastic sheathing can release toxic fumes when burned, adding to the danger. Because of these safety concerns, the NEC typically requires more robust wiring methods in Type 5 assembly use buildings. These alternative wiring methods are designed to provide greater fire resistance and minimize the risk of fire spread and toxic fumes. Common alternatives to Romex include firstly, electrical metallic tubing, secondly, intermediate metallic conduit, and thirdly, rigid metal conduit. These types of conduit are made of steel or aluminum and provide a protective enclosure for the electrical conductors, shielding them from physical damage and fire. In addition to metal conduit, mineral insulated cable is another option for Type 5 assembly use buildings. Mineral insulated cable consists of copper conductors insulated with a mineral compound, such as magnesium oxide, and enclosed in a copper sheath. This type of cable is highly fire resistant and can withstand extremely high temperatures, making it suitable for use in hazardous environments. The specific requirements for wiring methods in Type 5 assembly use buildings can vary depending on local codes and regulations. It is essential to consult the most recent edition of the NEC and any applicable local amendments to ensure compliance. The NEC provides detailed information on wiring methods, conductor sizing, overcurrent protection, and grounding requirements. In addition to the NEC, local building codes and fire codes may also have specific requirements for electrical installations and assembly occupancies. These codes may address issues such as emergency lighting, fire alarm systems, and smoke detection systems. To ensure compliance with all applicable codes and regulations, it is recommended to consult with a qualified electrical engineer or licensed electrician. These professionals have the knowledge and experience to design and install electrical systems that meet the required safety standards. When selecting wiring methods for Type 5 assembly use building, it is important to consider factors such as the building's fire rating, the occupancy classification, and the potential for physical damage to the wiring. The wiring method should be appropriate for the environment and capable of withstanding the expected conditions. It is also important to ensure that the wiring method is properly installed and maintained. Improperly installed wiring can create fire hazards and electrical shocks. Regular inspections and maintenance can help to identify and correct potential problems before they become serious. In summary, Romex cable is generally not permitted in Type 5 wood frame assembly use buildings due to its flammability and lack of fire resistance. The NEC requires more robust wiring methods, such as metal conduit and mineral insulated cable, to provide greater fire protection and minimize the risk of fire spread and toxic fumes. Consulting with a qualified electrical engineer or licensed electrician is essential to ensure compliance with all applicable codes and regulations. Furthermore, in addition to considering the wiring material, other important aspects of electrical installations in assembly buildings include proper grounding, circuit protection, and adherence to relevant safety standards to safeguard the building's occupants. Consider proper overcurrent protection as well. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow, which can cause overheating and fires. It is important to select overcurrent protection devices that are properly sized for the circuit and that meet the requirements of the NEC. Grounding is another critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to prevent electrical shock hazards. It is important to ensure that all electrical equipment and wiring is properly grounded in accordance with the NEC. Proper labeling of electrical panels and circuits is also essential for safety. Clear and accurate labels can help to prevent confusion and errors when working on electrical systems. Labels should identify the purpose of each circuit and the location of the corresponding overcurrent protection device. Regular inspections of electrical systems are important to identify and correct potential problems before they become serious. Inspections should be performed by qualified personnel and should include a visual examination of wiring, connections, and equipment. Any damaged or deteriorated components should be replaced immediately. Training for employees who work on or near electrical systems is essential to ensure their safety. Employees should be trained on the hazards of electricity, safe work practices, and the proper use of personal protective equipment. Emergency procedures should also be in place in case of an electrical accident. Furthermore, arc fault circuit interrupters, or FSIs, are devices designed to detect and interrupt arc faults, which are a common cause of electrical fires. The NEC requires FSIs in many circuits, particularly those serving bedrooms and other areas where people are likely to be sleeping. Ground fault circuit interrupters, or GFCIs, are devices designed to detect and interrupt ground faults, which can cause electrical shock hazards. The NEC requires GFCIs in many locations, particularly those where there is a risk of contact with water, such as bathrooms, kitchens, and outdoor areas. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges which can damage sensitive electronics. The NEC recommends SPD for many applications, particularly those involving valuable or critical equipment. Remember to adhere to the specific articles of the NEC to determine the proper wiring methods. Firstly, Article 300.11 addresses securing and supporting wiring. Secondly, Article 310 covers conductors for general wiring. Thirdly, Article 334 specifically addresses non-metallic sheath cable or Romex. Consult these articles along with others relevant to the specific installation to ensure compliance with the NEC. Always prioritize safety by using appropriate wiring methods.